Hey everyone, Mr. Fransky here. In this video we're going to go over the free response questions that have to do with the implicit differentiation problems that you were given in that packet. So this is important for developing skills for how to solve an AP style problem. So students will be able to solve AP level implicit differentiation problems. Let's give it a shot. And some of these are going to require a calculator. The first one I believe is calculator OK. We're only going to have to use it one time though, I think. So implicit differentiation is the name of the game here. So, consider the curve defined by this equation. Show that the derivative is 4x minus 2xy over x squared plus y squared plus 1. So we have to use implicit for that. So the derivative of the first part is going to be 6y squared, y prime. Then it'll be plus 6, and we have to do product rule, so 2xy. So that's the derivative of the x squared part. Plus, now we'll leave the x squared alone, and we'll have y prime. And then minus 24x, and then plus 6y prime equals 1. No, 0. Ooh, Mr. Fransky, that was close. All right, now we got to get our y primes all together. So I have 6y squared y prime plus 12xy plus 6x squared y prime minus 24x plus 6y prime equals 0. Let's keep the y primes on. Well, let's take a look at how they did it. So it looks like they have positive x squared, positive y squared. So yes, I'm going to want to leave everything on the left for the y primes. So I'm going to have 6y squared y prime. I'm going to pull the y prime out. 6y squared, and then I'll have plus 6x squared. And I'll move everything to the right side. So we'll have, looks like 24x minus 12xy. And now we can divide. So y prime is 24x minus 12xy divided by 6y squared plus 6x squared. And I'm missing something. What am I missing? Where did I miss something? Oh, the 6y prime? Yes, that's what I'm missing. So I have a plus 6 in here. Okay, so I have a plus 6 there. All right, so now it's not quite what they have, but it's close. And if I divide everything by 6, so multiply by 1/6 over 1/6, that gives me 4x minus 2xy divided by y squared plus x squared plus 1. Check. We got what they got. Thank goodness. All right, so now we're going to write an equation for all the horizontal tangent lines to the curve. So we know for that we have dy dx equal to 0, right? Because the slope is 0, horizontal. So that means that the derivative has to be 0. For that to happen, 4x minus 2y gotta be 0. So 2xy. 4x minus 2xy. Well, this shares a couple things in common. It looks like I can pull out a 2x. So I pull out 2x. I have 2x times 2 minus y equals 0. So I got a couple options here. Either x equals 0 or y equals 2. Okay, well, let's see if we can make some sense out of those things. So let's first do x equals 0. So if x equals 0, let's go back to our original problem. So if x equals 0, we have 2y cubed. 2y cubed plus 0, that's nothing, plus 0, plus 6y equals 1. Now, this is where the calculator comes into play. Okay, so I'm going to switch over to my calculator real quick. I think I've got it up and ready to go. I hope I do. Get out of here. Keep. Go to my calculator. I do. Okay, so I'll split this screen so we can see what we're doing. So what we want is 2y cubed plus 6y to equal 1. So I'm going to graph that. Could use the solve function, but I'm going to do it as if I didn't have a CAS. So I'm going to add a graph. And I'm going to have to do this with x's because that's the only way that the calculator graphs. So I'm going to do 2x cubed plus 6x, and then I'm going to do 1. So 2x cubed plus 6x, and then I'm also going to graph 1. And I have to see when they intersect right there. So I'm going to go to Menu, Analyze Graph, Intersection, left side, right there. There we go. And I'm in my calculus document, so it gives me lots of decimals. So I'm going to use 0.1651 because I like to go to 4 decimal places. So I'm going to do 0.1651. Big. So it could be when y equals 0.1651. And if y equals 0.1651, remember the derivative is 0. right? So that's going to be the equation of the horizontal tangent line, right? Because if the slope is 0, then it's just a y equals. It's a horizontal tangent line, so it's just y equals. Now, for y equals 2, let's try that into the function. So if y is 2, let's see, we have 2 times 8, and then plus be 12x squared. Ooh, minus 12x squared. Those go away. That's nice. And then we have plus 6y. Well, we said y was 2, so plus 12 equals 1. This doesn't look good. 2 times 8 is 16, plus 12 equals 1. That is never true. So that can't happen. So there must not be any spot where y equals 2. So the only thing that works is when x equals 0, y equals 0.1651, and the slope is 0. Now, if you didn't like that I just wrote y equals, we could write y minus 0.1651 equals our slope, which is 0, times x minus the x-coordinate, which was 0. But this 0 just cancels everything out here, so that's 0, and then you just add 0.1651, so it's a horizontal line. All right, cool. Let's get away from the red. I don't like the red. Back to purple. Okay. So next up, consider, so using that curve, so the line through the origin with slope -1 is tangent to the curve at point P. Find the x and y coordinates of point P. All right? So the line through the origin, 0, 0, with slope -1. So that would look like that. Oh, we know the equation of that line. That's y equals -x, right? Because it's through the origin, slope of -1, is tangent to the curve at point P. I'm going to make up where point P is. It's probably going to be wrong, but I'm going to assume it's there. And then it does something like this. Okay? All right, now they want us to find the x and y coordinates of that point. So I want point P to be x comma y, and I want to know what those two things are. Well, if it's on the line y equals -x, that kind of gives me a leg up. I know that y has to be equal to -x, so it's on this line. It also has to be on the curve. So let's kind of say what we know. We know that y has to be equal to -x. We also know it has to be on the curve. What else do we know? Well, we know that if the slope of this line is -1, then at this point, the derivative must be equal to -1. So dy dx has to be equal to -1. So we know this is -1. We also know y is equal to -x, so we can do a substitution in here. Let's see which one is more complicated. I don't think it really makes any difference. Let's make all of the y's. Let's turn them all to -x's. So we have 4x minus 2x times -x divided by x squared plus -x squared plus 1. That's all got to equal -1. Now we have one variable, so hopefully we're going to be able to solve this. Looks like it should end up being quadratic, so I think we'll be able to. So I'm going to multiply by the bottom. I'm going to kind of combine two steps into one here. We got 4x plus 2x squared equal to, so I'm going to have -1 times this whole mess on the bottom. I have x squared plus x squared, that's 2x squared. Multiplied by -1 is a -2x squared. 1 times -1 is -1. So all I did was take this whole bottom, brought it over here, and multiplied by -1. So -2x squared minus 1. Now let's get it all on one side. 2x squared plus 2x squared is 4x squared. And then, let's see, 4x squared plus 4x minus 1 equals 0. I think we can factor that. Let's see, 2x and 2x, 1 and 1, and looks like it's going to be, is that going to work? Did I do something wrong? Let's see. Oh, this is a plus 1. I was going to say, something seems wrong. All right, so that makes everything positive. So this is equal to 0. So we have 2x plus 1 squared equals 0. The only thing that solves that is x equals -1/2. So if x is -1/2, y is the opposite, so it's -1/2, 1/2. Now, if I were an excellent calculus student, I would plug this into that function right there to make sure that it is indeed on the curve, because it's possible all of this happened, but it's not really a point on the curve. I'm not going to do that. If you want to plug that in there and make sure that it works out, really we should do it, but because it says that there is a line, it says the line through the origin with slope -1 is tangent to the curve at point P. That guarantees that it does work out, so really we don't have to check it. It'd be good practice, but I don't want to cube -1/2. I don't really want to mess with that. So anyway, moving on. All right, the other problem. So consider the curve x squared plus 4y squared equals 7 plus 3xy. First thing, once again, they give us the answer. Gosh, I love it when they do that. So let's see if we can find that derivative. So 2x plus 8y y prime equal to, derivative of 7 is nothing, just 0. 3 times product rule, y plus xy prime. Get all our y primes together. So this is 3y plus 3xy prime. Let's get all the y primes. Let's see, they have a positive 8y, so let's get all the y primes to the left. So we have 8y y prime minus 3xy prime equal to 3y minus 2x. So y prime times 8y minus 3x equal to 3y minus 2x, and we divide y prime 3y minus 2x divided by 8y minus 3x. Hey, check it out. That's what they got. Awesome. Next up. Show that there's a point P with x coordinate 3. X is 3, so we have 3 something, at which the line tangent to the curve P is horizontal. That tells us that dy dx is equal to 0. Find the y coordinate of P. Okay, so we have dy dx, 3y minus 2x over 8y minus 3x. They tell us it has to be equal to 0, and they tell us the x coordinate is 3. So let's replace these x's with 3's. So we got 3y minus 2 times 3 over 8y minus 3 times 3. Equal to 0. So that's 3y minus 6 over 8y minus 9 equals 0. Well, really only the top has to be 0, right? Because if we multiply by the bottom right now, it's just going to be 0 times that whole mess. That doesn't matter. So 3y is equal to 6. Looks like y is equal to dose. So our coordinate pair is 3, 2. Nice. Y coordinate of P, y equals 2. Now they want us to find the second derivative for that point. All right, I'm going to keep that 3, 2 in my back pocket. So we have to take the second derivative, d squared y dx squared. So low d high, 8y minus 3x. D high is going to be 3y prime minus 2 minus high d low, 3y minus 2x. D low, 8y prime minus 3 over the square of slow we go. 8y minus 3x squared. So they want us to find this at 3, 2. Well, we have some y primes in there. Now, if you remember, we have two choices here. One is we can take this thing, this honker, and put it in where both of these y primes are. That sounds messy. What I'm going to do instead is put 3, 2 into it. So I'm going to evaluate this at 3, 2. Okay, so I'm going to evaluate this thing at 3, 2. And that will give me 3 times 2 is 6 minus 6 again. It's 0. We know that, right? They told us the tangent is horizontal. And it's kind of nice to check again, but on the bottom we get 16 minus 9. Okay, so that's 0. So both of these y primes turn into 0, which is really nice. If you had put the whole fraction in, you'd be dealing with a whole mess. So we got 8y minus 3x. And I can just plug all these things in, actually. So 8 times 2 is 16, minus 3 times 3 is 9, times 0 minus 2, minus 3y is 6, minus 2 times 3 is 6. Hey, that's 0. Don't care. Don't care what that is, because that's the whole thing 0. All divided by 8y minus 3x squared. So that is 16 minus 9 squared. So this gives me 7 times negative 2. Divided by 16 minus 9 is 7 squared. That's 49. That's negative 14 over 49. Divide them both by 7 if you really want to. Negative 2/7. Cool. Fun problem. And not too hard. Awesome. I think that's all I've got for you in this one. Just that free response questions. Love you guys. That's why I'm here. Have an excellent day. Filled with lots of math, hopefully.